Okay, so we're going to work with the CAS system. We talked briefly about this last time. And the CAS system lets us know of our trig ratios. So we have our sine ratio, our cos ratio, and our tangent ratio. It lets us know which ones are positive in certain quadrants, this being quadrant 1, 2, 3, and 4. The way we usually write it is we start in the bottom right if we're going to spell CAS. So C-A-S-T, the A standing that for all trig ratios are positive in the first quadrant. C is for cos, S is for sine, and T is for tangent. In other words, saying those are the only ratios positive in their corresponding quadrants. Now, they've given us a question that says to solve for the angle when cos is equal to a ratio of negative 8/17. Okay, so right off the bat, I can think of my CAS system, right? I'm looking at a cos value that is negative. Well, that means we're not looking for an angle in quadrant 1 because cos is positive there. And cos is also positive in quadrant 4, so we're not looking for an angle in there. In other words, our angles need to be within this quadrant. Now we know we're always starting from this line here when drawing our angles, so in other words, we have an angle that's going to be greater than 90 degrees. Right? It has to be greater than 90 degrees to be in quadrant 2, but less than 180. And we'll have to have another angle that's greater than 180, but less than 270 in order to be in quadrant 3, and that's part of the error we have there before, right? So there are a couple ways we can go about doing this. One of the ways you did this is you just typed in with your calculator the cos inverse. So you took this ratio here. You had cos negative 8/17. You found the inverse of it for the angle. So cos inverse is negative 8/17. My calculator, there it is. So we have negative 8 divided by 17 to the inverse of cos. Gives us 61.92. Let's just approximate it. Oh, wait. Shouldn't have came out like that. When you typed it in, you got 100 and something?
Yeah.
The inverse? Did I not hit the negative? Let me double check. Inverse. Oh, that's why. There you go. Negative 8, that's why. Divided by 17. And then the inverse of cos. There you go. 118. That's okay. That other number is going to be important to us. Okay? So we found an angle of 118. Great. That makes perfect sense for us. In other words, we have some angle here that we know is going to be 118. But what do we really want to be focusing on with this information? What you did to start is we want to set up a triangle, and the acute angle that's going to be in the very first quadrant, we can just use that small acute angle to find the rest of the angles. So instead of actually typing what we did in here in the calculator, we can solve this as if it was positive. Okay, so just like I had accidentally typed into the calculator a second before. So what we'll do is we'll set up this triangle in the very first one. We know that since cos is equal to the opposite over the hypotenuse, we know we have two of the measurements, right? Our hypotenuse here is going to be, now I know this isn't to scale with our numbers on the side here, but this distance is going to be 17. We're unsure this distance because that would be considered opposite of this acute angle we're going to find. Sorry, cos isn't opposite. Adjacent. The adjacent side to this will be 8. Now, when they talk about negative 8, all they're saying is they're going back the other way, correct? In other words, the x value is negative 8, which would make sense. Again, it's not to scale with these numbers. The x value here is negative 8. The terminal arm here is 17, and we're trying to find out our y. Now, the y isn't imperative to solve, but it's something nice in order to do this. I don't really have to use a cos ratio to do this. Because I've been setting up right angle triangles, there's a very quick way I can set this up. Do you happen to know what it is? To find out the...
Pythagorean theorem.
Yeah, that's right. We can just use Pythagorean theorem to find out that y value. So let's do that very quickly. If that is 17 is our hypotenuse squared, is equal to 8 squared plus, and we'll say y squared because y is what we're looking for. It'll be 17 squared minus 8 squared is equal to y squared. And I think you said when we worked it all out, would you get 15 on the dot? Let's find out. We'll use our calculator. 17 squared subtract 8 squared is equal to, yeah, and then we square root that value, 15 on the dot. Perfect. So in other words, our y value here is 15. So we're just piecing together information right now. So we have all of our information about a right angle triangle. But like we said, we want to find this acute angle. Well, there's a couple ways we can go about doing that. One of the ways is now that we have all of these measurements to the angle in the first quadrant, this one being positive, this value being positive, right? What we can do is we can actually use our trig ratio to find this acute angle. Another way we could have done it, because we already know that this larger angle here is 118, is we can take 180 and subtract our 118 because this angle inside, this interior angle, will be identical to the acute angle in our quadrant 1. Whichever you wanted to do to solve it is completely fine. Okay, so let's say we go about doing it both ways. With the acute one, we used our cos ratio from before. We'll call it this angle. But this time we're going to have positive 8 over 17. And in our other answer, we said we take 180 and subtract our 118 from it. When we do the cos inverse of this, we accidentally did it in our calculator at the beginning, right? What value did we get?
62 degrees.
Yeah, approximately 62. And when we subtract these two, we get 62 degrees. Perfect. So we know that this acute angle in here is 62 degrees, though it's not going to be one of our answers because we know cos is positive and we're looking for a negative ratio. Well, with that 62 degrees, we can continue to create right angle triangles off of the x-axis. So we have 118 as one of them. Starting at 180, we're going to create another identical triangle going down this way with an acute angle of 62 here. Well, if we're starting at 118 and then we're adding another 62 degrees, sorry, not 118, 180, what will this entire angle be that comes all the way around? What would be the fastest way to solve that?
Add 62 to 180?
Yeah, let's add our 62 to 180. So we get our 180 degrees plus 62. We should get 242. 242. Is that what they found when they're looking at theirs?
Yes.
Yeah, I think that was it. Okay. So that was a long process, right? But really the very fast way to do this is, it was great what you did if we were only looking for one answer. And the reason, again, we were looking for there is because they told us between 0 and 360, which means we're finding all angles that were the cos ratio is negative, but in all four quadrants, so between 0 and 360. Well, we quickly eliminated quadrant 1 and 4, okay? You could find our answer in here, where we had our obtuse angle, but the fastest way to do it may be to just take our acute angles and then reference from our x-axis every time, okay? Does that kind of make sense how we did that? Yeah?